Hello guys, I'm gonna provide solution to this given question. Of course, this is a Cambridge further maths question, paper one. Okay, we have to find the value of this in terms of n. Okay, so this is summation r equals 1 to n, then r plus 1, then in bracket of r plus 2. So when you look at this is just like a product of three consecutive numbers. So you are now looking for sum of that from 1 to n. So first thing to do is to expand this, and when you expand this is going to give us a quadrat, going to give us polynomial. Okay, so r equals 1 to n. The first expansion there becomes r squared plus r, then in bracket r plus 2. So let's proceed to expand the two brackets now. R equals 1 to n, then this will give us r cubed plus 3r squared plus 2r. So this is the final result you obtain for that. Okay, so now what are we going to do after this? Now when you have sum of something like this, now I mean anytime you have sum of a plus b, this can be written as summation a plus summation b, okay, or sigma a plus sigma b. So and that is exactly what you are going to apply here. So by the time you do that, this becomes sigma r equals 1 to n r cubed plus r equals 1 to n. So this should be 3r squared, but 3 there is constant and that can be factorized. So we have 3 outside, then r squared. While the last term there, we write that as 2 summation r equals 1 to n r. Okay, so now what's going to happen here? Now remember, we are asked to simplify this or find this in terms of n. So first thing you have to understand there is that for each of these you have a formula for that. Okay, and that will be given in the formula sheet, although I'm not using that here. But for those of you that you are just coming across with this in the first time, so we have this to be summation r equals 1 to n r cubed, that is given to be n squared over 4, then n plus 1 squared. Okay, and for summation r equals 1 n r squared, so that one is given to be n over 6 n plus 1, then 2n plus 1. Okay, and the last one, which is summation r equals 1 to n, that is given to be n plus 1 n plus 1, then over 2. Okay, so we're gonna make use of this in this equation. Let's call this equation 1. So what everything we have here now, we're gonna make the substitution in 1. Okay, so that we can simplify that to be in terms of n. So by doing so, now we have this here can be written as this, that's n squared over 4 n plus 1 all squared, then plus 3 n over 6 n plus 1, then 2n plus 1. All right, and the last one, which is 2n n plus 1 over 2. Okay, so yeah, when you look at these three terms, we have two factors there common to each of these. N is common there, then n plus 1 is also common. When you look at this, is n plus 1 n plus 1 n plus 1. Okay, so the best way to go about this is to factorize to bring out the common factor. Okay, and that's going to be n plus 1 brackets, then you use close brackets here, or square bracket n plus 1 over 4, then plus 3 over 6 can be reduced to 1 over 2 2n plus 1. All right, 2n plus 1, and the last time, since we factorize n and n plus 1, 2 over 2 is 1. Okay, so sorry about that. Yeah, 4 can be factorized down, 1 over 4 I mean, so n plus 1 now over 4. So you take xm of what you have in the brackets, and that will be n plus 1, then plus 2n plus 2n plus 1, then this is going to be what, 4. Yeah, so don't, this aspect is very important. You can't leave your answer like this. So the best way to go about it is to leave your answer in the simplest form, and the only way to leave it in simplest form is by factorizing it. Okay, so expand that will be n squared plus n, then 4n plus 2, then plus 4, and now you have n plus 1 over 4 in bracket of n squared plus 5n plus 6. All right, yes, you can choose to leave it like this, but when you look at what you have in this bracket carefully, you see that this is a quadratic expression that can be factorized. Okay, so and the what this means is product of 6 sum of 5, so which 2 and 3. Okay, so you have n plus 1 over 4, then that will give us n plus 2, n plus 3. So in summary, the final answer to that is going to be 1 over 4 n plus 1, n plus 2, and n plus 3. And that is the solution to the first aspect of the question. All right, so the next thing is the B part of the question. Okay,